Yeah, recorded. Hi, Isaac.
Hi, Tamar.
How are you?
Good. How are you?
Fine. So in this video, we are going to go over the ITK-snap tool we use for lesion segmentation and creating lesion maps within our patient that has undergo strokes, right? They have lesion and we want to segment the lesion, and we're going to demonstrate how we're doing this. So first, that's just a brief explanation for why do we need these lesion maps. So there are a few reasons we can think about. It can help the normalization in pre-processing of the fMRI data. So normalization of brain lesion, like brain with lesions, can be tricky and harder than regular brains. And it's challenging because the damaged tissue and enlarged ventricles and the lesion itself distort the brain and make it harder to segment as compared to a healthy brain. Okay, more reasons for creating lesion maps is estimating the lesion volume. So we want to know what exactly, like how many voxels or what the size of the lesion. So we first have to segment it and then normalize it to standard spaces and see what the size of the lesion is. And I think if you have anything to add on top of what I'm saying, please do. In the same, under the same reason, maybe if we want to see the overlapping lesion maps from different individuals. So we first have to segment the lesions, and then we take it from the native space to the standard space. So we normalize the lesions, and then we can create an overlapping map and see how much of the lesion is overlapping between different subjects when we overlay the lesion on top of the other. So this is another reason why we want these maps. And then if we, during the analysis of our fMRI data or other sequences of acquiring imaging data, so if we want to mask out the lesion area, and we, for example, want to say we want to track activation in brain regions, but we don't think there is real activation in the tissue, right? So we want to mask it out instead of dealing with artifacts that might come as signals from these regions. So we can create a map of the lesion and then mask it out during our first level analysis in ESPM. And so this is for statistical calculation later on. And we can also think about estimating the proportion of spare tissue in specific region of interest. So we are masking out the lesion from the brain, and then we are looking at specific ROI. So let's, for example, take the IFG, and we're taking the anatomical region of the IFG, subtracting the lesion area, we mask it out from the lesion map we created, and then we can say, okay, this is the proportion of the spare tissue in the IFG. So all these reasons are kind of related to each other, but this what we thought of what can help us creating these lesions, and probably there are more reasons too. So there are more than one tool available for creating lesion maps, such as the MRI Cron, FSLI, ITK-snap, ANTS, and probably more toolboxes that are not mentioned here. And we chose the ITK-snap tool for a few reasons. I think it is very easy to use. I'm sorry, why is it black? But it's very easy to use, and so most of it's through GUI and not commands. It has a good documentation. So if I go to their website here, the website, and you can see there is documentation. It's very well explained. There are many videos that you can find on it. There is a 90 minutes brief tutorial about how using the tool, and so this is a good reason for using it. And let me go back to the slides. And yeah, it was originally developed for segmenting organs and tissues in the body. So it has clinical goals. And we would like to show a demonstration for how we use it for creating the lesion maps in our patients. So I think I'm about to stop sharing my screen, and you'll go over the demonstration and explanation of how to do this.
Mm-hmm.
Thank you.
Yes. Thank you, Tamar, for that great introduction to the topic. And yeah, so I will give a quick demonstration of how we use ITK-snap to segment lesions for our patients. Just to confirm, Tamara, you're seeing just my ITK-snap window?
Let me see. Yes, I do.
Okay. All right, yeah, so I guess the caveat with that is that this is, specifically how we use ITK-snap and how we have found it to be useful for us, but there are lots of there are other good resources out there for more general, I guess, uses of ITK-snap or other specific uses. Okay, so the first step for us is going to be just loading in the structural image files that we're going to use to draw these lesion maps. So for that, we're going to go here to open image, browse, and I'm going to have to navigate to the files. So first, I'm going to open the T1 for this patient.
And maybe I can add you that you can upload the T1, but as well as the DICOMs, so it recognizes both of them. You don't have to convert first.
So yeah, nifty as well as DICOMs, right?
Yes.
Yeah. Yeah, and then something else that ITK-snap allows you to do is to then add a second image. So something that we like to do is, if it's available, add the T2 flare, because that can be very useful for identifying lesioned areas. They can, particularly white matter areas that are lesioned, will show up much more readily on a T2 flare than in a T1. So we find it useful to use as a reference. So for that, we can go to File, add another image. And it's right here.
And maybe while you are uploading that, I will add that usually in fMRI images, you'll probably have T1 for sure. And then because it has a good contrast of gray, white matter, and CSF that we are using in preprocessing. So it's not necessary to add a T2, but as Isaac said, it's a good, it adds good contrast in specific regions that show better the lesion regions. But we are still, at the end of the day, we are only saving the T1 image with the lesion, like the lesion on the T1, not on the T2, just does make it easier to look and detect lesions.
Okay, so first, one quick trick we can use to make our job a little easier is a shortcut that is Control-J. Will optimize the contrast for us, so everything is a little easier to see. So now I'm going to walk you through the automated segmentation process that we use. So first, you're going to click this icon here for segmentation, and then you can adjust this window if you want. I just keep it in the full window there. And then you're going to click Segment 3D.
So what I'm seeing on the screen now, so we have the first T1 and then T2 flare, right?
Yes, so you can change your view up here. So this is your T1, your T2 flare, and then this is going to be your speed image, which is what the software uses for the segmentation.
Okay.
So you'll see that change as we set this up. So there are a few different modes that we can use, 4 different modes: thresholding, classification, clustering, and edge attraction. So I am only going to show you the one that we use, which is classification. So basically the way this works is we're going to mark certain areas as examples of particular tissues. And then the software is going to use a machine learning algorithm to then classify those tissues, which will be used for the segmentation. Okay, so the next thing I'm going to do is I'm going to set up our labels. So I like to label these with names that help me remember what everything is. So I usually will do a label for, well, I'll do 2 labels for the lesion. And
why do you have to?
Yeah, so what we find with these lesions is there is there's some heterogeneity in the intensity in these lesions,
Yeah.
right? And so a lot of times it's difficult for the software to capture all of it in one go.
Yeah.
So what I'll typically do is segment the darker part of the lesion,
Yes.
and then go and segment the lighter part of the lesion, and then we can add those together
Okay,
later.
makes sense. So the algorithm find it easier to segment later.
Yes, exactly. And then do a label for gray matter, white matter, and CSF. And then you can get even more detailed if you want and add a label for bone, for the skull. You can get as specific as you want, but it just gets to be a lot more work up front. So I'm going to leave it at that. Okay. So when you're actually creating or marking your examples, what I like to do is you can use this button here that you can see it on each of the views to blow up one specific view. I usually look at the axial view. And so then you can zoom in a little bit and do this in a little bit more detail. So I typically use the brush in 3D to mark the examples. And
3D means interpolation to make it clear, right?
So as I understand it, so 3D means like you're painting for example, if the brush style is a square, you're painting a cube,
yes,
rather than painting a two-dimensional square, right?
Yeah.
Okay. So we can start with the darker part of our lesion here. So just to kind of make sure I am kind of systematic about it and I'm capturing kind of the whole thing, I'll kind of start at one. Yeah, so start at kind of one end. So we can see this, definitely the darker part of the lesion here. So we'll mark that. And I kind of just scroll through and mark very clear examples of this darker part of the lesion.
Mm-hmm.
And at some point we might have to change our brush size a little bit when it gets harder to fit in there.
So as we can see, you're not going slice by slice because it's a semi-automated tool. So you're just sampling from very clear slices.
Exactly.
Yes.
Okay, so we have our examples for the first part of the lesion, right?
Yes.
And then I'll scroll back up to the top and we'll mark the second part of the lesion. So this is kind of what I'm talking here, this kind of lighter intensity area that we would still want to call part of the lesion, right?
Yeah.
So now I'm going to mark these. And it's a little bit rough because it's kind of a continuum, right?
Yes.
But
we want to hope that the algorithm will catch it, like with no border within these two. But even if it will, then we can later on manually edit it.
and you may have to go back and do some editing of your examples if you find that the classifier isn't doing as good of a job as you'd like it to, but this is kind of a place to start.
Yeah. Can you go, I mean, in this particular image, it's sequence of T1, it's clear. Like, can you just go for the T2 and show how the lesion looks there?
Yeah, so that's a great point. So we can kind of scroll through and see how our examples are lining up with what we see on the T2 flare.
Mm-hmm.
So you can see those lighter parts tend to be, or at least some of them are actually like hyper intense on the T2 flare, right? And also that kind of contrast between the darker part and the lighter part is a lot clearer on the T2 flare.
Oh, can you stop to think like that, please? Hi back.
Hi. Okay. So since by this point you have seen how to create these examples, we thought it would be best to stop the video in the interest of time, and I went ahead and marked the examples for the rest of the tissues. So I'll just scroll through quickly so you can see what those look like.
So maybe you can like add a quick example of each label. So we have a lesion 1, lesion 2, and then what else did you add?
Yeah, so where's the slice where we kind of have, so we have our lesion 1.
And then you switch
Lesion
labels
2.
to lesion 2.
Yep.
Okay.
And then I switched labels to white matter, which is the yellow.
So yeah, can you show like one example of each? The white one.
So actually mark an example?
Yeah, just one example maybe.
Sure, yeah. So I'll mark an example of white matter here. And then I'll mark an example of gray matter. A lot of times you need to use a smaller brush size for gray matter because it's hard to get in those small spaces.
Yeah.
And then I'll mark an example of CSF in the ventricle there.
Yes.
Okay.
And I see most of your examples are on the left side. Like if you scroll over the different slices. So why mostly on the left for gray white matters?
Yeah, so that's a good question. So, I mean, really, the issue is we have this big lesion that's taking up so much of the left hemisphere, right? So it's hard to find good examples of a lot of these tissues in the left hemisphere. That being said, for the process that we use, it is important to try to find some good examples in the left hemisphere because we use location as a feature in these in the machine learning algorithm. So if you mark only tissues, healthy tissues on the in the right hemisphere, you may end up with a situation where it's only segmenting the white matter on the right hemisphere and not recognizing it on the left hemisphere, or not recognizing it as well in the left hemisphere. Okay. All right. So speaking of that, we'll go into this more button here lets you change some of the parameters specific to how this classification happens. So as I mentioned, we like to use the voxel coordinates as features. And then we also do use the intensities of voxel's neighbors as features. And we've just found that we've gotten better results doing that.
Yeah.
You can also increase the number of trees and the tree depth, and just have to be aware that the higher these numbers go, the longer it's going to take, and the greater the chance that it's going to crash and you're going to lose your work. Okay. So another important lesson, as often as you can, save your work so you don't lose it if the software crashes.
Yeah, though it's only possible to save it whenever you're done with segmentation, right?
True, yes. So so mid segmentation, it's not possible to save. So there's a couple different options for saving, and we'll go over those when we get through this segmentation process.
It's a good place to jump in and saying that we are quickly going over the labels, brushes, sizes, saving, because we are assuming that if someone wants to use the tool, you first go to the documentation and go over the 90 minutes course or whatever to understand how it works. And we are assuming by this time you already know how to use the tool, and that's why we are skipping all the fine details information for what it means using different options, right? So it's just an example.
Exactly. Okay, so now we are ready to train the classifier. So that's this button here, and it will take just a minute, and then we get our speed image. So this is what our segmentation process is actually going to be using. So we can scroll through this and see. So right now we're looking at the lesion 1 as the foreground. So that's going to be the white areas. So you can see it's seems to have done a pretty decent job. It's hard to tell exactly without overlaying it with the T1, but all of our examples seem to be showing up in the white areas there. So that's good. We can also look at our other lesion. So you can see those are also looking pretty good.
how to detect the gray, white, and CSF. Can you go over it quickly?
Yeah, you can look at those also. So there's your gray matter,
which is really nice,
and your white matter. So some of this tissue outside the skull here is showing up on that, but it's not going to be an issue for us.
No, it's far from the lesion, and we are not going to segment it anyway. So yeah.
And then our CSF. And this is where that using voxel coordinates as a features really came in handy, because it's just based on intensity alone. It's very difficult to tell the difference between kind of this lesion 1 and the ventricle, right? But you can see it actually did a really good job of separating out the ventricle from the lesion using that.
Yeah, can you show it again? Like it was more option, right?
Yeah, so
yeah,
that's this option right here.
Yes,
include
okay,
voxels coordinates as features. Yep.
Perfect. Yeah. Okay, we're ready for the next stage.
Okay, yeah. And so one option from here, you can select multiple foregrounds at the same time and try to segment the whole lesion at once. Sometimes that works okay, especially if you've done a really thorough job of marking examples. And sometimes it doesn't work as well, and it's you're better off kind of choosing one, segmenting it, and then segmenting the other and adding them together. So for simplicity, we'll go ahead and just do lesion 1 for this example. So we're just going to go to next.
And get to the cool part.
The cool part.
Yeah.
The fun part.
The fun, like the bubbles.
The bubbles.
Chewing.
So this is the part where, depending on how many, on the settings that you've chosen, may take some time.
But till now, it seems like I've done a decent job for classifying the different tissues. Mm-hmm. What we can tell.
Yeah, and it'll be hard to tell until we do actually run the segmentation and then overlay it, or see the overlay on the T1. But
yes, but it's probably faster than going slice by slice and marking it. Wouldn't you say so?
Oh, for sure, yes.
There we go.
So we are on to the next step. So this step is going to involve adding some seeds or bubbles that we are going to use as starting points for the segmentation. I typically start with just a single bubble and see how it goes from there. I like to set up everything thoroughly enough in the earlier steps that you don't have to mess around with lots of different bubbles in different places, and that you can just have a single bubble expand to fill the entire lesion. Yeah. That's not always possible, but I always kind of use that as a starting point.
Okay. So we have a speed image, actually. You're doing this on either of the images, right? Doesn't really matter. But
yeah, so sometimes I look at the speed image. I guess it's good to look at the speed image because you do want to like ensure that
it's within borders.
Right, exactly.
Yes. So to wrap it, like just now we are looking at one segmentation of one label, which is the lesion 1, and you see that it's in the white color within a speed image. The white color is what the algorithm detected for being the label 1, and we want to create the shape of the map by adding these funny, cool bubbles.
Yeah, and something that I didn't mention on previous stuff that I can go back and show you when we get through this process that we may have to address, because you can see a lot of this is pretty gray rather than being white like we'd like it to be. So you can also adjust the bias on this speed image, which can help you to shift it one way or the other to include more kind of in that label, more or less, depending on how you need to adjust. So once we have our bubbles, we can go on to the next step. And I usually like to watch this part on the T1, just so I can see how it's filling in all the spaces. Okay, so from here, we're just going to basically start expanding this bubble. We have a play button here, which will start it. If we want to restart it, we use this kind of rewind button. But it's important to note it's not just going to go back a little bit; it's going to undo everything that's been done. So
It's just the bubbles, though.
right, just the bubble expansion, right? You're still going to have all your bubbles that you've marked, but they're going to go back to how you originally marked them.
Yeah.
And then you can also proceed with just a single iteration at a time, or use different step sizes by using this button. Okay, so I'll just go ahead and run this, and we'll see how it goes.
Yeah. Do you set any other parameters at this stage?
So you can, and we'll see how this runs, and then we'll look and see if we can adjust some other parameters.
Okay.
So
right, is it still growing?
The other thing we can do is to change to this window so we can see it in all of the. So it seems like we need to either add more bubbles or possibly change the that bias that I was talking about, but it does seem to actually be expanding into this area now.
Yeah, so the more iterations, probably the more extended it will be.
And if it's running pretty slow, you can always increase the step size so it'll run faster. And you can also see that it's kind of like missing some spots in here, right? That are those may get it, included into the other lesion label, but also adjusting that bias that I was talking about can also help to get more of that. So I think this is pretty much expanded as far as it's going to go. If it goes any farther, it's going to start leaking into places that we don't want it to go, probably. So this seems to have done a decent job of getting that those darker parts of the lesion, right?
Yes.
Yeah. So the parameters that Tamar was mentioning are right here. So if we find that we're having some issues with how the bubbles are spreading, we can go into here and adjust some of these things. So this first one is just the force. So how strongly it's pushing to expand. So in our case, if anything, it was expanding very slowly, and so we probably wouldn't want to mess with that. But this other one, the smoothing, is kind of deals with how this how the expansion deals with kind of small spaces. And so by increasing this, you create kind of a smoother boundary that's less likely to leak into small spaces. So that might help with areas where you see the expansion leaking into kind of your subarachnoid space or something like that.
Yeah, you can actually play with it just for a demonstration and then press the animate and
so we can animate that and adjust. So you can see these little lines here represent the force on the speed image, right? And then we can play with the smoothing curvature. So you see that it's a very kind of smooth boundary there, whereas if we go down really low, it's a lot more likely to kind of fill in those kind of narrow spaces, right?
Yeah. Okay. So now we're going to segment the second lesion.
Yeah, so I think this did a pretty decent job on that part. So we'll go ahead and click finish, and it will save the segmentation for that that part of the lesion. So at this point, this is where we definitely want to save. So we can save the segmentation, which is definitely what we do want to do that. Another thing that we can do, so when you save that, that's basically saving your segmentation as a Nifty file, right? But another thing you can do is you can save your workspace. So when you do that, it's going to save things like your specific labels that you've created and things like that.
Yes.
And I think it'll even save your examples that you've marked for the classifier.
Yes.
So you can open that back up at any time and kind of start where you left off.
Yeah. Can you update now in the fourth window, update it to that we'll be able to see the shape of the map that is created now? Yes.
Yeah, so this window will show you the three-dimensional shape of.
So when you press the update there, this is what you got for the lesion map for this specific classifier. So you can either save this shape or save the whole workspace as Isaac said. Okay, great.
Okay, so now we'll go in and do the same thing for the second portion of the lesion.
Mhm.
And just to show you what I was talking about earlier, so let's look at the speed image. And if we go into these more settings here, so the classifier bias is what I was talking about. So, so you can see you can kind of adjust this to kind of include more or less, right? And maybe we want to go a little bit more in this case.
Why?
So just because, so where it, partly because when we did the first part of the lesion, I felt like it was kind of missing a lot. There was a lot of areas that were clearly part of it that were kind of gray here that maybe it wasn't going to capture. And there was a lot of little spaces, right? Okay. So if we go this way a little bit, it'll tend to include a lot more and have fewer gaps, right? Yeah. So the biggest thing is, like, as long as you don't start seeing things that are not part of the lesion, especially things that are not part of the lesion but are continuous with the lesion, yes, you don't want to have those showing up as white, because it's definitely going to leak into those places. But I think that this looks okay. You can see that, you know, parts of the ventricle maybe are showing up here, but they don't seem to be continuous. Maybe a little bit here, but that's probably lesion anyway. So, but I think this looks pretty good, so we'll go with it and see how it goes.
Yeah. So by saying it's not continuous, you're not worried, because as long as you're not adding a bubble there, it's not going to extend to these regions, right?
Right, exactly.
So the bubble is going to extend. This is important, maybe. The bubbles are extending only within borders of what you can see on the screen. So if you can see in other places, like regions that are also were recognized mistakenly by the algorithm, but are not continuous with what you actually want, it doesn't have to bother you, because as long as you're not adding bubbles there, you're all good.
Yeah, exactly. Okay. So this might take a minute again, so we'll go ahead and pause the video for a second.
Okay.
Okay, so we are on to adding bubbles for our second portion of the lesion. So you can adjust the size of the bubble either before or after you add it. You can add it and then adjust. Okay, so there's our bubble. And I'm going to look at the T1 while we do this. And actually, we'll look at all three views. And maybe we'll increase the step size a little bit. So we'll run a little faster. All right, and then we'll see how it goes.
And the bubbles are always red. Like, don't worry if your label is green, it's only red. It's okay.
Yeah, ultimately, the only thing that really matters is what is active in this window right here when you click that finish button.
Yeah. But it still seems very slow in this case.
Yeah, in fact, it seems to be not really expanding. So maybe we have chosen a bad place for our bubble. So you can always go back in these steps, and it will save your future. Well, I guess you can go back from here and it will save your bubbles. So it's a little surprising to me, because it looks pretty clearly within. Sometimes if you make your bubbles too small, they won't expand. So that might be the issue here.
So you can either increase it or add more bubbles.
Yeah. And maybe we'll try adding another bubble too, and see what that does for us. Okay. So we'll try that again. And there we go.
Oh, yeah. In this case, you even want to make it even slower, maybe.
And we'll go ahead and look at all the views. Okay. So it seems like it's not really growing anymore. So we'll go ahead and stop it. And you can see that seems to have done a pretty good job of getting all the places that our first one missed, right? And there might still be some gaps in there, but it seems to have done a pretty good job. Okay, so we're going to check to make sure we've got the right label active here, or lesion 2, so that looks good. So we'll go ahead and finish. Okay, and there you go. So there are some little gaps in here that we can either address by going back and rerunning one or the other of these, or with just some manual editing.
Yeah. I mean, if you update the shape now, like the lesion map,
update that
down there,
and so you can see.
Yes. So this is actually our lesion map.
Okay. Okay. So because we segmented each of these separately, rather than choosing both as the foreground, which could have been a good option for us, we did them separately. So since we did that, we need to merge these into one label. And I am not aware of a simple way to quickly do this. So the trick that I use, which is pretty quick, but maybe not that
It's okay.
Yeah.
So just to add this, like if you take this map and you save the segmentation here, we've tried that. So going to segmentation, save the lesion map. We found out that if you take it out to, for example, MRI Chrome or other tools, that your map is not binarized. So we want a binarized map of 1 where the lesion is 0 elsewhere. In this specific case, that you have 2 labels, so you ended up with 1, 2 for the 2 colors, and then 0 elsewhere. So we might want to unify the 2 classifiers here to 1 lesion map with the values of 1, like a binarized map. So that's how Isaac found how to do it.
Exactly.
I think it's okay.
Thank you for that very clear explanation,
Sure.
Tamar. So this is how I merge these labels. So basically, you can choose the active label as the label you want to end up with, which lesion 1 makes sense for that, and then you want to paint over lesion 2, and then you can make your brush very large in 3D, and then you just paint over big swaths of it, and then we'll just scroll through until we see green again.
Cool.
And
yeah, so that's mean the active label, the lesion 1, the red one, is going to be paint over all the green colors, and you end up with 1 label basically, which is a cool solution, I guess. And again, as we mentioned earlier, it's not necessary. If you want, you can use the 2 classifier of the 2 lesions and add the bubbles simultaneously to both of them and end up with only 1 lesion.
Exactly. So I'll just scroll through real quick to make sure there's not any green left. And there are some other ways you can check that too, but just a visual check. Yeah, there's our lesion. So we can update the 3D, and there it is. Yeah, so that is how we segment our lesions with ITK-snap. Do you have any other comments, Tamar?
No, so we can save the workspace if we want to later, for any reason, go back to these specific classifiers, as you said before, or we can save the segmentation of it's a nifty file of the lesion map and then take it to other toolboxes to see how it looks like, how it overlays over the brain. And in the next video, we are going to explain how we use this lesion map in our pre-processing steps and first analysis in SVM12. So thank you, Isaac, for your very good demo. And I hope it's going to help us. I'm sure it will.
I hope so.
See you.
All right. Thanks, Tamar.
Bye.